Hello everyone, welcome back to the channel. This is Nirmit and today is 23rd May. We are doing problem of the day. Check if array is sorted and rotated. So आज का question is a easy question and many people that's why ignore easy question very much. But still easy questions also teach you a lot, sometimes even more than those hard ones. So yeah, let's jump into the question. So the question says given an array nums return true if the array was originally sorted in non-decreasing order, then rotate some number of positions including 0, otherwise return false. There may be duplicates in the original array, okay. And an array rotated by x position results in an array B of the same length such that bi double equal to ai plus x percent a dot length for every valid index I. Before seeing examples, let's see what are our constraints. Our constraints is very less, so हम लोग एक big of n square या n cube type का solution भी कर सकते हैं. But here on this channel, we will be doing the most optimal solution. So let's understand our test case first. So the question says कि अपने को एक array दिया है जो कि already sorted है 1 2 3 4 5 6 7 8. Suppose this is the array एंड फिर हम लोग इसको किसी एक पोजीशन के अलॉन्ग रोटेट कर दिए. सपोज 5 के अलॉन्ग रोटेट कर दिए तो अपने को मिल गया 5 6 7 8 1 2 3 4. एंड अपने को ये वाला पार्ट दिया है एंड अपने को ये बताना है कि वॉज दिस एरे ओरिजिनली सॉर्टेड और नॉट. अगर सॉर्टेड है, अगर इस एरे से हम लोग इस टाइप के फॉर्म में जा सकते हैं तो ट्रू, अदरवाइज फॉल्स. सपोज एक एग्जांपल ले लेते हैं. सपोज आर एरे वॉज समथिंग लाइक 1 2 4 3. तो इसको हम लोग जितना भी रोटेट कर ले दिस विल नेवर बिकम सॉर्टेड, क्योंकि या इसको अगर मैं किसी पोजीशन के अलॉन्ग रोटेट भी कर दूं, आई रोटेट इट सपोज अलॉन्ग 4 3 कुछ भी मैं कर दूं 4 3 1 2, मैं यहाँ पे कुछ भी कर लूँ, दिस एरे वोंट बिकम सॉर्टेड बिकॉज यहाँ पे इफ यू सी केयरफुली हियर देयर आर टू पीक्स एक्चुअली, तो दैट्स व्हाई दिस एरे कैन नेवर बिकम सॉर्टेड. नाउ व्हाट एक्चुअली इज अ पीक हियर? सो for an array to be actually sorted in the entire array there should only be one maxima, there should be only one where a peak is happening. Suppose यहाँ पे अपना peak क्या है, 8 यहाँ पे peak है क्योंकि 8 से बड़ा कोई नहीं है. 7 यहाँ पे अपने पास 7 था, 7 was less than 8 and 8 was greater than 1, तो यहाँ पे अपना एक पीक हो गया ये, एंड इसके अलावा यहाँ पे कोई पीक नहीं है. सो इफ देयर इज ओनली वन पीक इन आर एरे तब तो ठीक है, वो सॉर्टेड हो सकता है एंड हम लोग ट्रू रिटर्न कर देंगे. बट यहाँ पे केस देखते हैं, यहाँ पे अपना दो पीक्स एक्चुअली. इफ़ यू सी केयरफुली, पहला पीक तो अपना इसको और अगर मैं वापस इसी फॉर्म में दिखे तो 2 से बड़ा है 4 and 4 is greater than 3. Yeah, so if an array cannot be sorted, there will be two peaks. Like here, one peak is 4, and if you see carefully, 1 is also another peak because 3 is greater than 1 and 2 is also greater than 1. So it's like a throw. So there should be only one such cliff type element. If there are two, then the array cannot be sorted. So let's think of our solution now. So here one solution which intuitively comes to the mind is the very brute force solution. You pick up find the minimum element in the array. Suppose this is our example. Let's delete everything else. Yeah. Suppose this is our array. So what is the most intuitive solution here? I find the minimum element in the array. Here it is 1. Then I keep the index of my minimum element. Suppose minimum element. Suppose that is I, and then I go from I to n minus 1, and I store all the elements in a different array, and then I go from 0 to I, and then I get 5 6 7, and then I sort my original array also. I get 1 2 3 4 5 6 7, and then I compare both these arrays. If they are same, then I will say ki okay, my array is sorted, this is my answer. And if they are not same, I will say that no, this the array was not even originally sorted, this is not possible. I will return false. Let's check for a case where it doesn't happen also. Again our same case, 3 2 1 4, sorry, 1 2 4 3. So here our minimum element, sorry, yeah, my bad. Let's check for another case where our element is not like where our array was not sorted and where the false will be the answer. Suppose 2 1 3 4. So here I find my minimum element, that is 1. I go from 1, that is my I, to n minus 1, and then I go from 0 to I. So and then I sort this array also. So I get 1 2 3 4. These both arrays are not similar, so I will return false. But if I go to code this solution, it will be a big O of n time, but space will also be big O of n because I am storing this somewhere, and that is taking my big O of n linear space. But I can do this solution in constant space also, that is big O of 1. So when I can do with a big O of 1 space, why will I use a linear big O of n space? So how will you do in big O of 1 space? the same intuition of our cliffs one. We'll see that if there are any inversions in the array, if at any place nums I is less than nums I minus 1, so in that case we will increase our inversion count, and if our inversion count is greater than 1, then we will output false, otherwise true. So let's jump to the code straightforward. Int is equal to nums dot size, and then I will store have a variable which will store my number of inversions, and then I go from for int I is equal to 1, I less than n, I plus plus. If anywhere my nums of I is less than nums of I minus 1, where I'm having a inversion, where the array is breaking the order of increasing order, there I will do simply a count plus plus. And if anywhere my count is greater than equal to 1, sorry, greater than 1, I will simply return false. Then I come out of the loop, and there's also one more case we need to check, that if nums of 0 is less than nums of n minus 1, then also I will do count plus plus. Now at first this seems a bit confusing, that why are we doing this, but we are checking for entire array what are our inversions. Let me give you an example. If I have 2 1 3 4, and if I was just going my normal logic running loop from 1 to this place and checking number of inversions, I will just have one inversion and my code will output true, which is false. One inversion is also here because if my array is getting sorted, if my array is getting rotated along a index, then if I get something new, like from that example, if 1 2 3 4 5 6 7 was rotated along 5, then I would get 5 6 7 1 2 3 4, and all the elements before the inversion index would be greater than all the elements after the inversion index. So here this nums 0 should be greater than nums n minus 1. So if it is less, then that is also inversion, and that's why I'm doing count plus plus there also. Now you will say, hey Nirmit, if my array is already sorted 1 2 3 4 5, then to my nums 0 will be less than only nums n minus 1, and then also I will do count plus plus. Yes, you will do, but in that case you will only have one inversion, and we are having a condition similarly, that if count is less than equal to 1, then we are returning true, and if count is otherwise, we are simply returning false. And yeah, that should work. Let's run it. Yo, and let me just submit it. Okay, so that's beating 100% of test cases, and yeah, that is our solution. I hope you enjoyed the video. If you got anything to learn, do like it and drop any questions or any feedback you have in the comments. Thank you. Signing off.